In this example problem, we'll have a person sitting at rest on a swing, and he shoots a bullet out of a gun that he's holding at an upward angle theta relative to the horizon. And the question is, what's the maximum angle that the swing achieves after the gunshot? So he shoots it out, and it goes up. And we'll say the velocity of the bullet coming out is v sub b. The bullet has mass b, the gun has mass g, the length of the swing is L, and the person has mass P. So now pause this video, solve it, tell me what this angle is, and then write down all the assumptions. So let's try to solve this problem. So the question is, how am I going to solve it? What laws am I going to try to consider? So let's just think about conservation energy first to see if that makes any sense. It's going to try to do the whole thing. We'll start out in the beginning. I have the system that's, we'll consider the person, the gun, and the bullet. We also could say the earth. It's up to us to decide what the system is, but I'll pick that. Okay, then surroundings, everything else. We'll say the initial state is the gun's about to be fired. And then final state is the bullet's at a velocity going out this way relative to the earth. It's shooting out there because you need to be in an inertial coordinate system. And the gun and the person, they're swung all the way up to this elevation, and they're at rest at that maximum angle. And make some assumptions. We'll assume the mass of the rope is 0. The stiffness of the rope is infinitely stiff, so it doesn't stretch. There is no drag force as it's moving, so no drag. And the person, the gun, and the bullet are particles, so we're not consider them rotating. So energy says that the total system energy in the final state is equal to this total system energy initial state plus the mechanical work done in that system by everything in the surrounding, plus things like the heat transfer into that system by anything in the surrounding. So now if I break that out, I would say, well, the energy in the system final state is the sum of energy of each thing. So we'll have the person, the gun, and the bullet each have their final energy, and the things in this, and then the system is my same three parts again. They're initial conditions, not final. So those three values, their total energy, work done on the person by the surroundings, and the gun by the surroundings, and the bullet by the surroundings, and then the heat transfer, thermal energy given to the person or the gun or the bullet by the system. Again, breaking that, we can take the energy of the person final. Well, he can have his rest energy, he can have his kinetic energy at the final, and he'll have his potential energy at the final. And so each one of these terms as far as energy of an element, being a person, a gun, and a bullet, will have these rest energy, kinetic energy, and potential energy in the final state. And then same thing for the initial state. We'll have the rest energy, kinetic energy, and potential energy. And then we'll have the works and the heat transfers. And now we know a couple things. The rest energy, we'll assume the mass of these parts, but also assume that that's another assumption, the mass is not changing. So if the mass is not changing, and in the speed of light in a vacuum is not changing, well then these for a person, those cross out the same, that crosses out, and that crosses out. And in the final state, we know we're saying the person is moved up here and he's at rest. He's not moving, so his kinetic energy is 0. Same thing with the gun. And in the initial state, the kinetic energy, we're saying nothing was moving at the beginning before I fired everything. So the gun, the person, and the bullet had no kinetic energy. So crossing everything we have, we end up with this term right here. So I have lots of potential energies of everything at the end, a kinetic energy. I have the potential of everything at the beginning. I have all the work done on the parts, the heat transfers. There's all kinds of forms of energy going on. So starts out with the chemical energy, the thermal, the kinetic, vibration, acoustic, rotational kinetic. It's just like, how do I solve this? I mean, you could. I mean, if you had all the information, you knew the energy in the gunpowder, you knew all dealing with that, theoretically that's a solution. But for this problem, this assumption of conservation energy is a very difficult thing to achieve, and you have to assume lots of things and have knowledge on lots of things. So this seems like this is not a path that's going to be very fruitful in getting us to the solution. One thing to also remember too is energy and work are scalars. So someone who's just knows equations and say, I have an equation, I'm going to stick something in there. So one could say, well, immediately after a shot, what if I just said the kinetic energy of the gun of the bullet is equal to the kinetic energy of the gun and the person? Well, clearly that's not true. I mean, that has nothing to do with this sort of relationship, saying that in the final state that somehow the kinetic energy of these things are related. See, if you understand, that makes no sense at all. Energy is state of energy of the system before, state of energy in the system after. It's not like some energy went that way and some energy went that way and they balance each other. There's nothing like that. Energy is a scalar. So clearly doing this one fits all, initial state to final state, could be solved. I'm not saying it's impossible if you know all these things. So, boom, a noise went off. Energy left the system. If I said, I'll ignore that. And particles everything's a particle, so there's no rotational going on. So, I'll ignore that. And this vibrational noise that's going on, I'll ignore that. Well, you still have all this chemical, the energy came from somewhere. And that as long as I draw my system, truly, energy, this equation is true. It's just that's not going to be a good way to solve this problem. So when I think about, well, what's a better way to solve it? So pause the video right now. Again, if you tried this way, the energy way, pause, think about something else.